Hello, all. Good evening. Welcome. So, we are back with our next algebra session, and this will be a very fun, interesting session. Diophantine equations. Diophantine equations. So, you might be wondering what this topic is all about. What is this? We have never heard of this thing or this term Diophantine equations. Now, uh, essentially, we have done equations which is linear and quadratics. So, as far as Diophantine equations is concerned, it's not a separate topic as such. It's not something in which I have to teach you some new theory. It is just the next extension of what we have already done with equations, and we are encountering questions in which there is a constraint, which is that whatever the variables we are dealing with, they need to be integers. They need to only take integer values. Sometimes we are saying they are integers, sometimes we are saying they are positive integers, which is natural numbers, sometimes we are saying that they are whole numbers, effectively the integer constraint. And that brings in a whole lot of new logics embedded into the problem solving approach. And the questions can be either of purely variable based analysis, or word problems can also be a medium to lead to such a scenario. Sometimes the questions might explicitly mention that, okay, here this quantity needs to be integer. Sometimes the quantity that we are talking about is by its very nature needs to be a integer value. So without further ado, let's jump into the problems and let's see how we are going to deal with such a context of the problems, right, where the variables need to be integers. Here's the first question. So, reading through it, you should be able to understand that we are dealing with a quadratic. At the same time, there is you can see there is a very direct mention of a integer constraint, right? So let's jump into this one. If both roots of the equation x square plus ax plus b equals 0 are positive integers p and q, right? So the roots are positive integers. Moreover, there is a further thing such that 7p plus 4q equals 153. Okay, then which of the following is not a possible value of b? B is the coefficient in the quadratic, which is the constant term, and the question is asking for us to determine the possible values of this term, this b, right? The roots also satisfy a linear equation 7p plus 4q equals 153 on the top of that. Wonderful. Cannot get better than that, isn't it? So what is b? The constant term. And since coefficient of x square is nothing but 1, so can I say this b is simply the product of the roots p into q? Isn't it? Because what is product of roots? Negative of the constant term upon the coefficient of x square. Not negative sign, only a constant term upon the coefficient of x square. So that is b over 1 or simply 1. So b is p into q. So basically, we are referring over here to the possibility of b, which is as good as the possibility of p into q, given that they satisfy this linear equation 7p plus 4q equals 153. Now, how do we figure out the integer solutions of this linear equation? Because that is what is the key thing over here, right? So we have to, if we have to find the integer solutions of a linear equation of this kind, what we need to do is find the first solution by hit and try approach. Means just start putting p equal to 0, 1, 2 until we get an integer value of q also, right? So let's do one thing. 4q is 153 minus 7p, isn't it? So from 153, keep on subtracting 7 until you hit a multiple of 4, isn't it? That's what you need. So 153 minus 7 would be 146. That's not a multiple of 7, of 4. If we again subtract 7, obviously that will be an odd number, so no need to subtract 7. But let's subtract 7 twice, which is 14, so that we land up to an even number. So subtracting 14 from this lands up to 132. And yes, that's such a value of 4q, such that q will also turn out to be integer. So what is the value of P and Q that we have obtained over here? Can I say if we have put P equal to 3 basically, because we subtracted 7 thrice, 153 minus 21 is basically 132. And when 132 is 4Q, so what is Q? 132 by 4, which is 3, 12, and then again 12, so 33. In that case, what is the value of B, which is as good as P into Q? 3 into 33 is 99. I don't see 99 mentioned anywhere. So this does not help me. But the point is that this solution 3,33 is the starting point. I know that 7 into 3 plus 4 into 33 equals 153, right? I know that. Now, I have put these brackets for a reason, right? Obviously, this value of P will only further increase, and correspondingly the value of Q has to decrease, such that the sum remains constant, because the sum of 7P and 4Q is constant and equal to 153. One has to go down, the other has to go up. So obviously P has to increase because it is at its minimum possibility. So 3 plus something and 33 minus something, the sum has to be balanced. Whatever I have to write here, look in this box over here, has to get multiplied with 7. Whatever I write over here in this box has to get multiplied with 4, and that has to be constant. Means 7 into something is 4 in the same as 4 into something, so that they effectively cancel off. The minimum possibility is 7 into 4 equal to 4 into 7 equal to 28. And in general, it could be any multiple of 4 here and any multiple of 7 here, which would maintain the sum as constant, yes or no? So my point is, the further solutions are going to be obtained by that we keep on increasing the value of P by the coefficient of Q, which is 4, and we keep on decreasing the value of Q by 7, which is the coefficient of P. So in fact, this is a generalization that we can always remember, that whenever we have a linear equation, we have to find the integer solutions, find the first solution by hidden trial, and then the subsequent solutions are obtained by this way, that each variable changes in terms of a multiple of the coefficient of the other variable. So therefore 3, keep on adding 4 to that. So 3 plus 4 7, 7 plus 4 11, 11 plus 4 15, 15 plus 4 19, and so on. But we cannot go up to infinity, because ultimately here Q is decreasing in terms of steps of 7, and we cannot go below the level when Q starts becoming negative. 33 minus 7 is 26, 26 minus 7 is 19, 19 minus 7 is 12, 12 minus 7 is 5, and this is the last step. We cannot go to the next step, because then 5 minus 7 negative. So these are the only possibilities of the roots P and Q, 5 possibilities. Let's check one by one what is the corresponding value of B. 26 into 7, 7 6 is 42, 4 carry, 7 to the 14, 182. Even that is not in the options. Don't worry. Keep on checking. 11 into 19. So 19 into 10, 190 plus 19, 209. Yes, that number I see in the options, and that is not my answer, because I'm searching for an option which is not a value of B. 15 into 12, 180. Again, I see that in the options, so that is also not my answer. 19 into 5, 95. That also I see in the options. That is also not my answer, therefore. So what we are left with? 133. Wonderful. A perfect question to start with to understand the integer constraint based on which the questions can be designed, right? And this is just a tip of the iceberg. I have brought a lot of different variety of questions to understand the different ways in which this integer constraint based problems can be designed. All right, ready for the next one? Here we go. Now this is not very mathy, this problem. As you can see, it's a more of a word problem, but there is something again inherent over here, and that is also mentioned very clearly. Age is only measured in integer values. Although this statement need not be mentioned, because that is always the default assumption. Even if the question does not mention this, age is always an integer. Nevertheless, I have made this statement so that there is no confusion. You cannot raise a point, you cannot raise a finger to the question, oh, the question is wrong, right? So Praveen's present age is twice that of Mahesh's age 4 years ago. There is a relation between the ages, which uh, through which we can write an equation. If age is measured in integer values, which of the following could be the sum of the present age? Again, look at the language of the question very carefully. The question is not asking which of the following is the sum of their present ages. Means what I'm trying to say, question is very clearly telling you that you will not be able to solve for the ages of the two people. Don't have that expectations. You're being asked for the possibility of the things, right? uh, so let's see what we can do over here. um let's say Praveen's age is P, Mahesh's age is M. Okay. So present age, I'm mentioning P and M being the present ages. So Praveen's present age, which is P, is twice of Mahesh's age 4 years ago, means M minus 4. We are going 4 years in the past. M minus 4. This is the equation. Okay. Then possibility is asked for the sum of the present ages, means we are asked for the possibility of P plus M could be what from the options. Now P plus M, let's substitute for P from the above, that P is 2M minus 8. So what we get, just add one more M to this, we get M plus 2M, 3M minus 8. Right, pretty ordinary. And from here we have to check. So 3M minus 8 equal to 38. Do we get an integer value of M? Well, 38 plus 8 is 46. 46 is not divisible by 3. So ruled out. Because the whole point is the variables are integers. So our equation should lead to an integer value. What if it is 49? 49 plus 8 is 57. Yeah, 57 would work. That's the answer. Right? That is the answer, because at 49, if the sum is 49, then from the equation we are getting an integer value of M, and that works. Right? So therefore, pretty straightforward, pretty simple. Ages are integers. You write the expression for the sum of the ages. You equate it to the option. Whichever gives you an integer solution is the correct choice. You can check that the others are not possible values, right? They are leading up to fractions. If I put it as 75, uh, then 75 plus 8 is 83, not a multiple of 3. If I put it as 44, 44 plus 8 is again 52, not a multiple of 3, right? That's why 49 works. Yes, Parth, very nice. B is the correct choice. All right, good. So let's see next one. All right, so here it is. Mehul wants to buy certain pens and pencils which cost 5 rupees and 2 rupees respectively. Well, we are in the golden age, I guess, in the 90s or so. 5 rupees, 2 rupees. The number of pencils bought should be at least half, but not more than twice the number of pens bought. So, right. So now we have a mathematical constraint in terms of the number of items bought. Right. So you cannot buy very less pencils. Also, you cannot buy very high number of pencils. There is a range from half to the twice of the pens. In how many ways can Mehul spend exactly? Not more, not 1 rupee less than, and not 1 rupee more than rupees 200. Well, so again, this is something similar to the first question that we did, where we have a linear equation, obviously, that we'll get in terms of the number of pens and pencils bought, right? So we have to figure out the integer solutions. We have already understood the basic mathematical logic behind the integer solutions of a linear equation. So if I say that there are X number of pens bought and Y number of pencils bought, then our equation is on this 200 rupees. So 5 rupee, 2 rupee. So the total amount spent will be 5 into X for the pens, and 2 into Y for the number of pens for the pencils, right? The amount spent on pencils. That should equal 200. Wonderful. Now, apart from this equation, we also have this constraint, pencils. So Y, the Y thing that we have should be at least half. Mathematically, what does that state? y is greater than or equal to of x by 2, and on the right, this is the lower limit of y, and on the upper limit y is less than or equal to of twice of x, because it should not be more than twice of the pen spot. So it could be equal to twice also, but not more than that. Both the sides we have equalities, right? It's an inequality statement, and in any inequality statement you should be very careful, is equality there or not? It is clearly there. Now let's find that first solution that we have by hit and trial approach, which is not very difficult to identify. What I'll do is I'll make one of the variables go to 0, although that is not possible, I know, but mathematically speaking, that will be our first solution from where we can start getting the solutions. So when y is 0, 5x is 200, so x is 200 by 5 or 40, right? That's the starting point. Now, as we have already seen, so x will decrease and y will increase now, right? Y is at 0, it has to only go up, and x has to keep on getting lesser, and that decrease in x has to be in terms of multiples of 2. So every time there will be a decrease of 2. So the solutions in general, can I say, are for x 40 minus 2k, right? And correspondingly y will keep on increasing in step multiples of 5 by the same multiplier, right? So 5k, right? Such that 5 into 40 minus 2k plus 2 into 5k matches up to exactly 200 for every value of k. Therefore, now with this we can come to this inequality, double-sided inequality, which will give us the valid permissible values of this k. This k has to be an integer, right? So take it one step at a time. We are given that y is greater than or equal to of x by 2. So this is x in general, and this is y, right? So y, which is 5k, is greater than or equal to of half of 40 minus 2k, which is nothing but 20 minus k. Perfect. So k plus 5k, which is 6k, is 20 or more, and k is an integer. What does that mean? 6 into 3 is 18. 18 is not more than 20. 6 into 4 is 24. 24 is more than 20. So k can be 4 and onwards, right? 20 by 6 is 10 by 3 is 3.33. I'm looking for only integer values. So k starts from the value of 4. On the upper side, y is less than or equal to of twice of x, right? So again, therefore 5k is less than or equal to of twice of 40 minus 2k, which means of 80 minus 4k. 4k comes here, so we get 9k is less than or equal to of 80. 9 into 9 is 81. 81 is not less than equal to 80, so 9 is not possible, but 8 and below is possible. 9 into 8, 72 is less than equal to 80. So k, the upper limit for k becomes 8. Therefore, k will start from 4 and go up to 8. So k can take the values 4, 5, 6, 7, 8. 5 different ways, 5 different combinations in which Mehul can spend exactly rupees 200 in buying his pens and pencils. And he goes happy and does his coloring work and his homework and everything. Right? And yes, so we can put the values of k and we can check that yes, these solutions satisfy our range, right? For example, for k equal to 4, if I put in this, right? So 40 minus 2 into 4, 40 minus 8, this will be 32, and this will be 5 into 4, 20. And this is fine because 20 is greater than or equal to of 16, half of 32, right? So all these further solutions will match this inequality as well, right? So again, this was on linear equations based integer constraint problem. But as I said, it is not just linear equations, but in general, a very wide scope of questions. Okay, so next one is a theta question. Now look at this, very logical question. The cost of 9 erasers, 7 sharpeners, and 5 pens is rupees 215. The cost of each item in rupees is a positive multiple of 5 and no two items cost the same. In other words, the cost of each item is a distinct positive multiple of 5. So, for example, if erasers cost 10 rupees, then sharpeners and pens cannot cost 10 rupees. They must cost some multiple of 5 but except 10. Wonderful. The cost of these items is given as 215. This combination, this combo. What is the cost of 3 erasers, 5 sharpeners, 7 pens? It's a theta question. Means the answer cannot be that cannot be determined, data insufficient. It's a theta question. You have to answer, and the answer is there to be had. And you have just one equation and 3 variables. Now you see, when we did linear equations, we did see some questions when there were three variables and 2 equations, and we were able to find something, some expression. But this is even one step beyond just one equation, 3 variables. And from that, we have to find this 3 erasers, 5 sharpeners, 7 pens. There is some logic here. There is some very deep logic here, which we have to understand. Now, here it is. What is your equation? Let's write the 3 variables. Let's call this that the one eraser costs X rupees, one sharpener costs Y rupees, one pen costs Z rupees. What is your equation? 9X, 7Y, and 5Z is 215. This is given. What is given on top of that? Each of these X, Y, Z are distinct multiples of 5. Right? They are distinct multiples of 5. Okay. And what is asked then? What is that we have to find? 3x, this is given, and this is what you have to find: 3x, 5y, 7z. Now here is what we can say. This 215 is not a very large number. This 215, this number holds the key. You see, X, Y, Z are multiples of 5. So the costs are not smallish. They are multiples of 5. So it's not like 2 rupees, 3 rupees things. It is, and they're distinct multiples of 5 also. So just consider that this 215 is a very small amount in respect of the fact that we have bought 9 plus 7, 16 plus 5, 21 items. If I do 21 into, let's say 5 also, 21 into 5 is 105. This is only 215. And I know that I cannot say that each item costs 5. It has to go even beyond 5. So this 215 is a very smallish number in that respect. What I'm trying to say, I'm repeating myself again and again, because I'm trying to tell you, we should focus on the minimum possible value, the minimum possible cost that could be associated with the items that we have bought under the constraint of them being distinct multiples of 5. What could be the minimum possible value of 9x plus 7y plus 5z, given that x, y, z are distinct multiples of 5? Just ask yourself this question. Obviously, the item which you are buying the most, you would want to associate the least cost with them. So you are buying the most of erasers, you would want to associate the least possible number, which is 5 rupees, with that. And as you keep on decreasing the number of items bought, you would then associate the higher cost with the next items, so that your cost is minimized, right? So the minimum possible value of this expression could have been 9 into 5. Agree? 9 into 5 plus then the next item, which is what the most, associate the next higher cost, the minimum possible, which is 10 rupees. So 7 into 10. And then again the next higher cost possible, the minimum possibility, which is 15 rupees, with pens which are bought, which you have bought 5 into 15. So what is this? what is this number coming to be? This is 9 into 5 is 45, then 70, and then 75. 70, 75, 145, 145 and 45. So this is 190 rupees. Now you have not spent the minimum amount, but the amount that you have spent is not way beyond that minimum limit. It's just 25 rupees more that you have spent. Now just think that this was the minimum that you could have spent, 190. If you have to spend 25 rupees exactly more, how would you spend that? Means which, so obviously you have to increase only the cost of something. You cannot change the number of items bought, right? So the actual value is not 190. We know it is actually 215. 215 is 190 plus 25. This 25 rupees that you have spent would only be obtained as an increment in terms of another 5 rupees being the increment in the cost of some item. So what I'm trying to say, if some items cost increases by 5 rupees, then the number of items that you have bought for that should be 5. So that 5 into 5, 25 rupees would match, and you have bought 5 pens. What does that mean? This 15 you need to go and make it 20. So that 5 into 5, 25 rupees more would come out, and you would spend exactly 215 rupees. Can I say that this is the only way, the unique way that you could have spent exactly 215 rupees? There is no other way, because it is just the one step ahead of the minimum possibility, and you could only spend that 25 rupees extra in only one way, by increasing the cost of pens by another 5 rupee, right? Therefore, what we conclude is that since your z has now become 20, so your x must be 5, your y must be 10, and your z must be 20. This is the only possible solution of the equation in 3 variables. Only one equation in 3 variables, but this distinct multiple of 5 constraint and this 215 rupees amount, you're able to nail down the values of all the 3 variables. Your core logic to the question was the minimum possibility and the amount you have spent are very close to each other. Therefore, this is it. And therefore, the answer to the question is the value of 3x plus 5y plus 7z, which we can finish. Right. So therefore, our answer is 3 into 5, 15 rupees, plus 5 into 10, right? These are the values. 5 into 10, 50, and 7 into 20, 140, is 140 and 50, 190, 190 and 15, 205 rupees. Wonderful. So next time you get this one equation, 3 variables, don't run away from the question. Think of this logic. It might work. Next, question 5. Coming back to variables, and as I said, the agenda is not just linear equations, not just quadratic equations, but anything where we have a question saying something is an integer. So here it is. If a and b are positive integers such that the cube root of 19a plus b plus the cube root of 19a minus b is 8, then what is the value of b minus a? Very nice. Now, obviously, the agenda is we can't solve this question algebraically. It's cube root and the sum of two cube roots. My God, what do you plan to do with this? Take the cube on both the sides? Oh my God, just do that once. Just see the complexity that will be thrown around. Just see it for yourself. Try to cube on both the sides. Obviously, we do this every time when we see any square root on both the sides, cube root. We take the power so that we are eliminating the radical sign. But no, that's not. I mean, that's not going to lead us to any simplification to the extent that we can solve it. The question is under the heavy weight of the constraint given at the top, which will guide the way to solve it. A and B are positive integers. A and B are not any random numbers out of thin air. A and B cannot be decimals, cannot be fractions, cannot be negatives also. They have to be positive integers only. What do? You look at the fact that you have cube roots. Two cube roots adding up to an integer. My God, how will you ever get that? Do you really think that these numbers could be irrational? It is not possible for two cube roots which are irrational to give us an integer value. Impossible. The only way that this equation could work out is that if the two parts themselves are integers. Means 19a plus b and 19a minus b both should be perfect cubes so that their cube roots become integers and they add up to 8. Given that a and b are positive integers, obviously the first term is greater than the second. 19a plus b is larger than 19a minus b. So the greater value will go to that and the smaller to this. 8 is a very small number. 8 is not a large number to be broken down into the sum of two integers, two unequal integers. The first possibility being 5 plus 3, the next one being 6 plus 2, the next one being 7 plus 1, and nothing else can be done after that. Only three cases are there. So we can do our hit and trial process, assign the values to the two cube root expressions as the cubes of these numbers, and then see, do we get the positive integer values of a and b or not? That's what it is. That's what is the process to attack this question. So what do? Case 1, 5 plus 3, which means that 19a plus b is the cube of 5, so that its cube root becomes 5. So 19a plus b equals 5 cube, which is 125. And that 19a minus b is the cube of 3, which is 27. And you simply add, because it's a simple expression ultimately. Plus and minus b cancels off, and you add, you get 38a, and that is 152. I recall 19 into 8 is 152. So 38 into 4 is 152. Oh my God, I have hit the jackpot in the very first hit and trial. I've got my a as 4. Done. Obviously b will come to be an integer also, right? So what is b? From the first equation, b is 125 minus 19 into 4. So this is 76. Yes, this comes to be 49. Done. B is 49. A is 4. Answer is 45, because he's asking for the difference of the two. B minus A, 45. Done. Now, you can check for yourself that 6 plus 2, 7 plus 1 combinations do not lead to an integer values of A and B. Right? We are done. We have got it. Right? So I hope by now, the agenda is clear. Diophantine equations means equations where variables are integers. Any kind of equations. Time to look at some previous year questions now. This is CAT 2003. Old is gold. I like old questions. They right. Any CAT question, even pick 1995. Nothing is, nothing is something that has gone off. Everything is there, which is as relevant as anything. Okay, so a very nicely built question. This one. A test has 50 questions. A student scores 1 mark for a correct answer, -1/3 for a wrong, and -1/6 for not attempting. Right? Not a question paper you want to be going in for, where you know that you have everything to lose if you have not even attempted. Okay, so if the net score of a student is 32, the number of questions answered wrongly by the students cannot be less than what from the options? So he's asking for the minimum number of wrong answers that the student must have answered, given that his net score is 32. It's a 50 question paper, maximum of 50 marks that you can get, because it's a 1 mark for a correct answer. So he's somewhere in the middle, 32. He has got 64% marks. So what are the equations that we can write? We can write an equation on the number of questions and the number of marks. There are 3 parameters over here. Right? The correct, the wrong, and the unattempted questions. Let's say X is the number of correct questions that he marked. y is the number of wrong, and z is the number of unattempted questions. There is no other fourth way he could have responded to any question. In any paper, you can only respond to a question in three ways: get it correct, get it wrong, and don't mark it, right? So obviously, x plus y plus z has to be 50, his total number of questions. And for the marks, so multiply with the corresponding values. So 1 into x plus minus 1 by 3 into y, right? We are accounting for the marks now. So x minus y by 3 and minus 1 by 6 into z, right? Minus z by 6. So that is 32. I'm seeing fractions, right? With the variables, I don't like that. I would want to see an equation with integer coefficients that makes our analysis workable. So let's multiply with 6, right? The denominators are 3 and 6. Multiply with 6. This is the first equation. I will just simplify the second equation first of all, which is that 6x minus 2y and minus z is 32 into 6, which is 192, right? That's my second equation. Now I have to analyze on z, on y, right? Y is the number of wrong questions that I have marked. Let me choose to eliminate any of the other two variables because I have to analyze on y, right? Okay, let's do one thing. Let's multiply the first equation with 6 and let's eliminate x, right? So I can say that 6x plus 6y plus 6z is 6 into 50, which is 3. And then let me subtract the second equation from this one, right? So because this 300 is larger than this 192, right? So 6x minus 6x goes off. 6y minus of minus 2y, so 8y. Basically I'm doing this minus that equation, so minus plus plus minus, right? So cancels, and this is plus and this is also plus. So 6 plus 1 7z is 300 minus 192, which is 108. Perfect. So we have got a linear equation which is a sum equation. So the sum of two things is constant. So if one has to be minimized, the other has to be maximized. Y has to be minimized, z has to be maximized. So we are searching for integer solutions here, right? You cannot mark 2.5 questions wrong. You cannot mark 3.75 questions correct, right? So therefore, do you understand the point that here, by inherent nature of the question, the variables involved are integers. That is inherent in the nature of the question, right? And therefore, you're looking for the minimum value of integer value of y, which satisfies this equation and gives us the integer value of z also. So uh, 7z needs to equal 108 minus of 8y. Means from 108, you're subtracting a certain multiple of 8 such that you're landing up to a multiple of z. So do you see, do you appreciate now that your y can't be 0 because 108 is not a multiple of 7, right? So this 32 is an exact score that you have to get. That's the whole point. So to get an exact score of 32, by analyzing the data, the metrics of the problem, the number of marks associated with each of the three types of responses, getting 0 wrong questions cannot lead to an exact score of 32, right? So y can't be 0. So I have to keep on subtracting multiples of 8 from 100 and 8 such that I lead to a multiple of 7. 108 minus 8 is 100. It's not a multiple of 8. So I'm keep on subtracting 8. Again, minus 8, I land up to 92. It's not again a multiple of 8, of 7, right? Keep on subtracting 8. 92 minus 8, 84. Yes, this is where I see, yes, 84 is 7 into 12. This is it. So for this, I had to subtract 8 thrice, right? Once, twice, thrice. For y equal to 3, right? I subtracted 8 into 3, 24 from 108. 108 minus 24 is 84. So therefore, our minimum possible value of y has been obtained as 3. That's the answer. All right. Now, CAT 2017, again, uh, so a completely variable based problem. The number of solutions xyz means he's asking for the combination of triplets of the values of the three variables xyz to the equation x minus y minus z equals 25, where x, y, and z are positive integers, such that x is less than equal to 40, y is less than equal to 12, z is less than equal to 12. A linear equation in three variables, positive integer solutions, range of all the three variables explicitly mentioned, the upper limit. You have to find all the combinations of the solutions x, y, and z. Let's jump in. How do you do this? You see, x has a higher range, right? It goes to a higher range than y and z. Y and z go up to 12 only. So I think we should attack on this x first of all, right? Let's rewrite this equation such that x is 25 plus y plus z. And think of adding these two integers to 25, these two positive integers to 25, and that gives us x. So obviously this y plus z cannot cross the limit of 15. 25 plus 15 will be 40. So one thing is sure, y plus z can be at the most 15. And on top of that, y and z are on themselves within the limit of 12. Wonderful. I think there's only one way. Let's jump into the y plus z expression and let's keep on assigning it the values from as small as it can be up to 15, and let's see all the combinations of y and z that we can get. It's a question of counting, isn't it? And we have to count it manually, but we are expecting to maybe get a pattern over here. What's the minimum possible value of y plus z? What is the minimum possible value of y plus z? Y and z are positive integers. 1 plus 1, 2. At the minimum, the value of y plus z is 2. 1 plus 1. It is nowhere mentioned that x, y, z are distinct integers. It's not like that. They can take the same values also, right? So how many solutions we have? How many number of combinations of the values of x, y, z we'll get? You see, our x, when we are fixing the value of y plus z, our value of x is automatically fixed. So it is all the combinations of the values of y and z which will give us the solution. So it is only one solution, which is 1 comma 1, right? So here I'm writing basically the values of y and z, not the solutions. I'm writing here the combination of y and z values, and here I'm writing the number of solutions, which is 1. If so, y plus z can only increase further. When it is 3, then how many solutions we'll have? Y and z can be 1 and 2 or 2 and 1. Obviously they are ordered solutions, so 2 solutions. When it is 4, y plus z, y and z can take the values of which are 1 and 3, 2 and 2, 3 and 1, 3 solutions. I hope you can understand the point. As we are increasing the value of y plus z by 1 every time, we are getting exactly one more solution. This pattern is bound to continue. Right? You can write few more values, you will keep on getting the same pattern, right? For this sum of y plus z being 5, you'll again get 4 solutions, which is 1 4, 2 3, 3 2, 4 1, right? So this will continue until, so let's keep on going further. Let's say we reach 12. We reach 12. Why I'm reaching to 12? Because I know y and z have that limit. So there will be something that will change at this point. For 12, we'll have the solutions which is starting from 1 comma 11, right? 2 comma 10, going all the way up to finally 11 comma 1. So from 1 to 11, these are 11 solutions, and till now we are just having the regular pattern, right? But things will change now slightly. At 13 also, we'll not have an issue. It will be going from 112 up to 112, then 211, and going up to 12 1. So still we'll have that pattern continuing, but we will have an issue at 14, because now we can't write 113, right? We have hit our upper limit on y. So therefore we can't write 113, so we'll start the solutions from 212, right? 212, 3 11 dot 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 until the other way around. At the last we'll have finally 11 3 and finally 12 2. So starting from 2 up to 12, these are 11 solutions. You see here the pattern breaks at this point. 1 2 3 4 5 6 up to 11 12, and then we are going down. Number of solutions has now decreased instead of increasing, right? So we had to be very careful with this, which makes the number of solutions here change. Finally, when this will be 15, then we'll have, again we can't write 1 comma 14. We will all we can all we also can't write 2 13, but we can start from 3 12, right? 3 12, then 4 11, and so on until at the last just flip around and 12 3. So x is going from 3 to 12, which are 10 values. From 3 to 12 are 10 values. So these two solution number of solutions 11 and 10 we have to count separately. Rest was in a pattern. So the total number of solutions is 1 plus 2 plus 3 plus 4 all the way up to 12, and this 11 and 10 is separate. We know the summation of first n natural numbers, so this becomes 12 into 11 by 2, right, which is 6 into 11. 6 into 13, 12 into 13 by 2, so 6 into 13, and this is 11 and 10 21, so this is 78 plus 21, so we have 99, right? Very nicely framed question, I would say. One of the good questions I've seen on this integer constraint, right? So you see, questions on this concept are plenty, right? They have been asked and in different ways. All right, time for the last question. CAT 2020. Okay, looks very nice, simple to read. Let a, b, and c be three positive integers such that the sum of a and the mean of b and c is 5. Let's start writing the equations. Obviously, we'll frame the equations, which are linear equations also. So the sum of a, positive integers, right? The sum of a and the mean of b and c. Mean, average. Average of two numbers is sum of numbers upon 2. A plus b plus c by 2 is 5. I don't like fractions in my coefficients. 2a plus b plus c is 10 is my first equation. I like that. Right? Always keep coefficients as integers. Only then you can do your analysis. In addition, the sum of b and the mean of a and c is 7. So b plus a plus c over 2 is 7. Write it in a way that you write a, b, c in that order. So you have a, you have 2b, and you have c, and that is 14. Right? Wonderful. So we have seen this many times. 2 equations, 3 variables. We have seen this many times. But this time the objective is, I mean, the objective is not to find, so we have to find the sum of a and b. So it is very clear we should be able to find each variable simply because we have the integer condition over here to satisfy. So you see the numbers are very small. I mean, the right hand side is very small numbers, right? So the given fact that they are the sum of 3 quantities, each of them being integers, we should be able to nail down on the specific solution that we have. But it cannot come by just randomly doing hit and trial. We have to go methodically. So obviously we can do the elimination of one variable at a time, and then let's see what happens. Let's subtract the two equations because c and c is the same, so we'll get something. This 14 is larger, so I'm subtracting the first equation from the second. So 2b minus b, which is b, and a minus 2a, which is minus a. Right? So I'm getting b minus a is 4. Second equation minus first equation. So b is a plus 4. Wonderful. So let's use this expression for b in any of the equations and get, because we need an equation of the form where we have some constant. So we cannot just work with this. Let's substitute b equal a plus 4. Let's in the first equation. What do we get? So 2a plus b, which is a plus 4, plus c is 10. 2a plus a, 3a, plus c, 4 goes over there is 6. 10 minus 4, 6. A and C are positive integers. They can't even take the value of 0. They are not even whole numbers. A multiple of 3 plus C is 6. That multiple of 3 can only be 3. It can't be 0. It can't be 6. Because if this is 6, then this is 0, which is not possible. So the only way this can work is that 3 into 1 plus 3 is 6. Means my A is 1 and my C is 3. So if A is 1, then what is B? A plus 4, which is 5. C is already 3. So what is A plus B? That is what the question is asking. It is 6. That's it. So when you hit this equation, then comes the aha moment. Oh, there's only one integer. There is only one positive integer solution to this equation. A can only be 1, C can only be 3. Right? So I hope this was fun, and we'll continue this further on. Right? I have more on this. So watch out for the next session. And do let me know on anything or anything that you have in your mind, anything to ask, anything to clarify, anything that you want to share on the chat box. Let me know your suggestions, your comments. Stay connected, and we'll meet again. Right? Thank you so much. See you in the next one. Thank you.